Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring solving quadratic equations by factoring. This is part 2 of a two-part lesson. In this lesson, we will be using the steps we learned in our previous lesson, and I will be factoring all the problems using the AC method. If you learned a different method of factoring, feel free to use the method you're most comfortable with. Now, solving quadratic equations by factoring is a topic that's difficult for some students. So please feel free to pause the video as needed and replay anything you didn't fully understand. All right, let's get started. So in our previous lesson, we learned to solve a quadratic equation by factoring. The first thing you have to do is make one side equal to 0. So in problem A, we have 4x squared minus 8x minus 5 is equal, 4x squared minus 8x equals 5. We want it to equal 0, not 5. So I'm going to start by subtracting 5 from each side. And when I do that, that gives me 4x squared minus 8x minus 5 equals 0. Now, because I'm using the AC method of factoring, I'll multiply the A, which is 4, times the C, which is negative 5. So my A times C is negative 20. I'll list my factors, 1 and 20, 2 and 10. And I'm going to stop right there because I'm trying to get a negative 8. I'm trying to split up the term negative 8. And I can do that with 2 and 10 if I make the 2 negative. So we're going to split up the negative 8x into 2x and negative 10x. So let me rewrite this problem here as 4x squared plus 2x minus 10x minus 5 equals 0. So all I did was I split this negative 8x into 2x and negative 10x. Now I'm going to factor by grouping. So the greatest common factor of 4x squared and 2x is 2x. And if I divide that, 4x squared divided by 2x is 2x. 2x divided by 2x is positive 1. Now in my second factor, I have a negative, in my second grouping, I have a negative. So I'm going to want to factor out a negative number. So the greatest common factor here is negative 5. So negative 10x divided by negative 5 is positive 2x, and negative 5 divided by negative 5 is positive 1. As I stated in the previous lesson, you'll know if you're performing this factorization correctly if you end up with these twinsies right here. All right, now we're going to put together our outsiders as one of the linear factors, and then the twinsies will be your other linear factor. Now I'll set them both equal to 0 and solve. So on the first one, add 5 and divide by 2. On the second one, subtract 1 and divide by 2. Now, it's important that you check your answers because it's very easy when you're factoring to make a sign mistake. For instance, instead of using 2 and negative 10, maybe you use negative 2 and positive 10, which would have given you an incorrect solution. So to check it, you use your original equation, and everywhere you see an x, you're going to replace it with your solution. So 4 parenthesis divide, oops, I want the division symbol. My first solution was 5 over 2, side arrow, parenthesis squared, minus 8, parenthesis, division symbol, 5 over 2, close parenthesis, whoops, side arrow, close parenthesis, and that equals 5. That's exactly what it was supposed to equal. Then I'm going to check my second solution, which was negative 1/2. So I'll just change this to negative 1/2 and change this 5 to negative 1/2. And that does indeed equal. So now I know my solution is correct. So I'm going to write my solution set in curly braces, 5 over 2, negative 1/2. All right, problem B. We have 6x squared plus 5x equals negative 1. I'd like you to pause the video and try this problem on your own. All right, welcome back. Let's see how you did. The first thing I did here was added 1 to this side and added 1 to this side. And that gave me 6x squared plus 5x plus 1 equals 0. Then I multiplied to find AC. So 6 times 1 was positive 6. So I can use 1 and 6, 2 and 3. But if I'm wanting to split the 5x, I want to use, in this case, the 2 and the 3. So 6x squared plus 2x plus 3x plus 1 equals 0. So again, if you're not familiar with the AC method, all I did was split the 5x into 2x and 3x. All right, now factor by grouping. So when I group up the first two, my greatest common factor would be 2x. And that would leave me 3x plus 1. Now, in my second group, 3x plus 1, the only common factor we have is 1. So we just write down a 1. And if you divide 3x plus 1 by 1, you're still going to get 3x plus 1. Put your outsiders together as your first linear factor, and then one of your twinsies as your second linear factor. Now set each factor equal to 0 and solve. So 2x would equal negative 1, x would equal negative 1/2, 3x equals negative 1, and x equals negative 1/3. Now, normally, I would have you check this on the calculator. However, for the sake of this video not being too long, I'm not going to show the check step, but please do not skip that step. It's the only way you're going to know if your signs are correct. So when I write my solution set in braces, I have negative 1/2, negative 1/3. All right, problem C. We have 3x squared minus 147. Now here in this problem, we only have two terms. So when you only have two terms, the first thing you do is look for a common factor. So I want the common factor of 3x squared minus 147. Now those numbers are both odd, so I know I can't use 2 as my common factor. I'm wondering if I could use 3 as my common factor. So let's try taking 147 divided by 3. Yes, it goes in evenly. So if I divide out a 3, that would leave me x squared minus 49 equals 0. Now, my parentheses will further a little further because I have a perfect square minus a perfect square, which factors to a plus b, a minus b. And we talked about this factoring pattern in our previous lesson. So if you need to, go back and watch that. All right, so this will factor to 3x plus 7 times x minus 7. So set each factor equal to 0 and solve. So 3 equals 0, that makes no sense. That's not going to give us a solution. Here, subtract the 7. Here, add the 7. So our solution set, negative 7 and positive 7. All right, problem D. 5x squared minus 30x equals 2x squared plus 72. So I'm going to start by subtracting 2x squared from both sides, then subtracting 72 from both sides, and that leaves me 3x squared minus 30x minus 72 equals 0. Now, normally I would go straight to my AC, but these are really big numbers. So I'm wondering, could I factor out a common factor? So I know 30 will divide by 3. Will 72 divide by 3? Let's check. Awesome. This is going to help us make our numbers that we need to factor much smaller. So I'll factor out a 3, which would leave me x squared minus 10x minus 24 equals 0. So now when I factor with the AC method, I'm only going to worry about what's in the parentheses, because as we saw in example C, the 3 equals 0 is not going to give us a solution. So if I multiply A times C here, 1 times negative 24 is negative 24. Then I list the factors of 24. 1 and 24, 2 and 12. But I'm going to stop right there because I'm trying to split up negative 10x. And if I were to make this 12 negative, 2 plus negative 12 would give me negative 10. So that means I can split this up into x squared plus 2x minus 12x minus 24 equals 0. So group this up. The common factor here is x. That would leave me x plus 2. The common factor of my second grouping is negative 12. And that would leave me x plus 2. So my final factorization, bring down the 3, and you'd have x minus 12. Write down one of your twinsies here. Now, again, when you set each factor to 0, this one's not really going to give you an answer. So the 3 is not really important to our solution. And here, I think you can just see that our solution set is going to be the opposite of what's in the parenthesis. Opposite of minus 12 is positive 12. The opposite of positive 2, negative 2. All right. The solutions to ax squared plus bx plus c have a unique relationship to the related graph for the function. In the examples below, we will explore this relationship. So let's look at example 2. The graph of y equals x squared minus 2x minus 15 is shown below. So this parabola, the equation for it is y equals x squared minus 2x minus 15. They graphed that right here. It formed a parabola. In part A, they want you to identify the zeros of the function. So remember from previous lessons, zeros are the same thing as our x-intercepts. So we have 2 of them in this problem, here and here. 1, 2, so negative 3 and x equals 1, 2, 3, 4, 5, positive 5. All right, so that's first step. Problem B. Solve the related equation x squared minus 2x minus 15 equals 0 by factoring. All right, so my AC would be 1 times negative 15, or negative 15. So 1 and 15 and 3 and 5 are my only factors. But I'm trying to split the negative 2x. So I want to use the 3 and the negative 5. So I'm going to use this factor pair. So let's split that. X squared plus 3x minus 5x minus 15 equals 0. Take out the common factor. Put your outsiders together and your twinsies together in one. Now take the opposite of what's in your parentheses. So positive 5, negative 3. There's your solution set. All right, part C. How do the zeros of the graph of y equals negative 2x squared minus 15 compare to the solutions of x squared minus 2x minus 15 equals 0? Well, they are the same. They are the same. The zeros and the solution set were the exact same. All right, look at example 3. The graph of 2x squared minus 3x minus 9 is shown below. Using the graph, estimate the zeros of the function. All right, so I have 1 here and 1 here. So let's see, negative 1. I'm in between negative 1 and negative 2. So I'm going to estimate the first one is something like negative 1.5. The second one, 1, 2, is positive 3. All right, problem B. Solve the related equation 2x squared minus 3x minus 9 equals 0 by factoring. All right, so if I want to solve this by factoring, my AC would be 2 times negative 9, which is negative 18. If I list the factor pairs, I get 1 and 18, 2 and 9, 3 and 6. Now I'm trying to split up the middle term, which is negative 3x. So I want to use this 3 and 6, but I need to make this 6 negative because 3x plus negative 6x would be negative 3x. So I'm going to rewrite my trinomial as 2x squared plus 3x minus 6x minus 9 equals 0. Factor out the greatest common factor. So 2x squared plus 3x divided by x would be 2x plus 3. The greatest common factor of negative 6x and negative 9 would be negative 3. And that would leave me 2x plus 3. Put the outsiders together and the twinsies together. So my solution set, take the opposite of the parenthesis, that'd be positive 3. On the 2x plus 3 equals 0, if you subtract 3, you get negative 3. Divide by 2, you get negative 3 over 2. All right. How do the zeros of the graph of y equals 2x squared minus 3x minus 9 compare to the solutions of 2x squared minus 3x minus 9 equals 0? Well, we know the 3's are the same, but here we got negative 1.5. Here we got negative 3 over 2. But remember, from middle school, negative 3 over 2 is equivalent to negative 1.5. So again, our solutions and our zeros are the same. All right, example 4. For a quadratic function h of negative 3 over 2 is equal to 0, and h of 5 equals 0. Which of the following is a possible equation for h in factored form? So here's what they're telling you here. They're saying that your solutions of your quadratic equation, your zeros, are negative 3 over 2 and positive 5. So we want to know which of these factors would give us negative 3 over 2 and positive 5. So for problem A, we have linear factors of 2x minus 3 and x minus 5. So if I take that first one and make it equal to 0, I would add 3, and I would get positive 3 over 2. I wanted negative 3 over 2, so I know A is not the answer. All right, let's go to B. 2x plus 3 equals 0. Subtract 3. 2x equals negative 3. And divide by 2. So negative 3 divided by 2. Ooh, that's promising. That checks out. But what's the opposite of positive 5? It is negative 5. And we wanted positive 5. So B, not the answer. All right, we already know 2x plus 3 gave us negative 3 over 2. So we can write that down. And x minus 5, the opposite of minus 5 is positive 5. Looky there, that's the first one that matches the zeros that they gave us. So we're going to go with answer choice C. And that concludes today's lesson, Solving Quadratic Equations by Factoring, Day 2.